This the lecture will cover on the dynamics of Earth and plate tectonic. It has been divided into part 1 and part 2. Now we will discuss on the first part of the lecture. For the learning outcome of this first part of the lecture are to understand the global structures of the Earth, realize the surface expression of the internal dynamic of Earth, and visualize the interaction of different plate boundaries in relation to Earth dynamics. So the occurrence of superficial regional tectonic and structure are closely related to dynamics of Earth, such as mantle convection. It led us to study more details on the interior of the Earth and to understand its mechanism. However, the interior of the Earth can't be directly observed. Thus, we conducted the study of the seismic wave that generated by earthquake to enhance our knowledge of the interior of Earth. The P wave velocity in seismic has been used to deduce the density of the medium, and it has been utilized in the Gardner's law. With this, we can divide the Earth into different interior layers. So density, this is the density layer of Earth interior. The first 200 km is lithosphere, and the density is about 2.7 to 3.3 gram per centimeter cube. The velocity of P wave and S wave are generally increased in deeper depth. However, there are some slowdown in the middle due to presence of the ductile layers. The upper mantle is started from 200 to 670 km, and the density is 3.3 gram per centimeter cube. P and S wave increasing in depth, in deeper depth. Same situations apply in lower mantle, which reach its lower boundary at 2,900 km. From 2,900 km to 5,100 km. It is outer core with density of 10 to 12 gram per centimeter cube, and it is in liquid state. S wave can't pass through liquid, thus it is dissipated in this zone. P wave is still present, but the velocity has been slowed down. Inner core is 5,100 to 6,370 km in depth. Both P and S wave are present and also increase with depth. The velocity of seismic wave are not always consistent increase with the depth as shown in the previous slide. Those discontinuity are recorded the boundary of the Earth's layer. Based on that, we know mohorophysic discontinuity or crust mantle boundary and Gutenberg discontinuity or mantle core boundary and other major boundaries. Those boundaries were mapped through seismic topography. The seismic topography can be in 2D or 3D. As you see in the image here, it is 2D seismic topography from South Philippines to the East Africa, and reach few hundreds kilometers in depth, which is mantle level. Different colors in the section indicate the velocity anomalies in the Earth interior. Red is slower velocity and blue is faster velocity. No velocity anomaly found in yellow zone. It clearly shows that mantle is not homogeneous. The velocity are closely related to density of the materials. Thus, we can interpret the condition in the Earth interior. The blue elongated zone at left show a cold relatively denser material in the mantle, represent the subduction plate. The reddish zone at the right emerged from bottom, indicated the hot lighter mantle materials are upwelling. Based on the physical and mechanical property of the Earth, it can be divided into lithosphere asthenosphere, mantle, and core. Lithosphere is represent the cold, rigid, brittle layer, and asthenosphere represent the weak and hot layer. The deformation in the lithosphere is often caused by dynamics of the asthenosphere. The upper part of lithosphere is crust. The crust can be divided into two: oceanic crust and continental crust, which has the distinctive chemical composition. Continental crust is thicker, commonly about 30 to 40 km. Oceanic crust is much thinner, around 10 km. The oceanic crust is lining the ocean floor, and the continental crust is surfacing the continent. Since the formations of the Earth, different events have occurred in the lithosphere. Some of them have been revealed by the records in the rock. By dating the minerals and rock, we have identified those events, such as oldest mineral found to be 44 billion years old, then oldest rock is around 4 billion years old. Other evidence in rock like geochemistry and fossil also provide the evidence of the paleo environment and paleoclimate, such as the earliest fossil found to be 2.5 billion years ago. Multicellular fossil is around 1.5 billion years ago, and great oxidation event occur around 2.4 billion years ago. The focus of the plate tectonic is on the upper section of Earth, which are lithosphere and asthenosphere. The lithosphere is a rigid outer shell composed of crust and uppermost mantle, and the asthenosphere is weaker layer, deformation in plastic way. The major boundary of lithosphere and asthenosphere is lithosphere-asthenosphere boundary, or short form is LAB. This boundary responded to the global evolution processes such as mantle convection and plate tectonic, such as lithosphere generation and recycling and modification. The modification can be due to tectonic like compression or extension and secondary mantle convection. These two images show the global evolution in the Earth interior, such as mantle convection affecting the LAB. Similar to tectonic process at the more shallower depth of surface, it also affecting the LAB beneath it. The tectonics include the study of Earth structure and at all scale. Specifically, it deal with regional scale or bit structure like oceanic ridge, basin, and mountain belts. Sometimes it can be called geotectonics to emphasize its global aspect. Based on the regional structure occurred in the Earth's surface, we can classify the area into different tectonic regimes. There are three main types of tectonic regimes. The first one is extensional tectonic regime. Second is compressional contractional tectonic regime, and lastly strike slip tectonic regime. The extensional tectonic regime is associated to the stretching and thinning of the crust or lithosphere. It can be found in divergent plate boundaries. Continental rift is the lateral spreading of the thickened crust, releasing bands in strike slip fault system, backup basin, and continental end of basin margin sequence where a detachment layer is present. The compressional tectonic regime is associated with the shortening and thickening of the crust or lithosphere. It can be found in the area of continental collision, standing bands in strike slip faults, and also part of passive margin sequence where a detachment layer is present, as called as a two truss. Strike slip regime is associated with the relative lateral movement of parts of the crust or lithosphere. The regime is occur at transform faults of oceanic crust at lateral offsets in extensional and truss fault system, in the overriding plate in zones of oblique collision, and at accommodating deformation in the foreland to a collisional belt. Based on the tectonic study around the world, we can notice the tectonic event, extension, compression, and strike slip that occurred through time. The colors in the map show the different tectonic belts which occur at certain time. The younger tectonic belt is more continuous and widespread because less erosion and deformation. The older tectonic belts are commonly patches due to strong erosion and overprint by later deformation. The Earth is dynamic, which is well represented by plate tectonics that unifying two phenomena, continental drift and seafloor spreading. The seafloor spreading explains that new crust or lithosphere plate form at ocean ridge due to mantle convection. The spreading pushed the old plate away, finally entered the subduction zone and diminished in mantle. The continental drift saying that the lithosphere consists of the rigid upper mantle and a crust is broken into a number of major plates and several minor plates sliding over the plastic asthenosphere. The lithosphere plates are all moving in different directions and at different velocity between 1 to 10 cm per year relative to each other. This figure shows the animation showing that how the continent Pangaea split up the plates and eventually reach the current position since 150 million years ago. The plate drifting rate is commonly few centimeters per year. This model show all the elements found in the plate tectonic such as asthenosphere, continental crust, oceanic crust. The mantle convection under the mid-oceanic ridge provide the mantle materials and generated the new oceanic crust, push the older crust away. Some plates have been pushed to trench and eventually the crust subducted into the mantle. Different parts of the tectonic setting led to various types of igneous rocks to form in plate divergent area or mid-oceanic ridge. The igneous rock is basaltic, intrusive and extrusive. In the oceanic crust, it is possible to find hotspot, also made out of basaltic rock. In the island arc, the plate subducted under another oceanic crust. The igneous rock can be various from intermediate to mafic composition. When younger oceanic plates subducted, the associated volcanoes can produce wide range of igneous rock from mafic to felsic composition. The Wilson second is explaining how a basin opened and finally closed. It started with rifting process in the stable continental crust. The crust started to stretch by normal faulting and also subside in the rifting zone. Eventually, the crust is thin enough and the mantle material are exposed. The mantle materials cool down and form oceanic crust. Now the seafloor spreading took over the role of rifting. New oceanic basin also formed. The former rifting zone now become passive margin. Later on, the old oceanic crust subducted at trench and entered into mantle. The oceanic is gradually consumed and becomes smaller. Finally, the oceanic crust is completely consumed and both ends of continent meet and collide, form mountain belt. Later on, the mountain belt region is stabilized. And becomes stable craton and waiting for another cycle of rifting. This figure is showing the major state of Wilson cycle as explained in previous slide, from rifting to seafloor spreading, subduction and collision. It will take about 200 to 300 million years to complete the whole Wilson cycle. As a conclusion, the Earth is made out of different layers which have different physical and chemical properties, as we utilize seismic wave to delineate those layers. The plate tectonic is initiated by the Earth's interdynamics, resulted as the regional scale surface morphologies and structure.